I think we have a basic foundation for unit tests on this projectOnto function, but I want to beef this up a little bit and give it a little more rigor. I know we're already passing the tests that we have, and I probably should have beefed up these tests before we pass the test, but it'll still make me feel good if we can do some more complicated scenarios. So here we did these two vector 3Ds, and they're pointing. Well, the first thing that's bugging me is they're all pointing in the positive direction. We haven't tried any negative values. And then I've also said that the dot product yields the cosine of the angle between two vectors, which is true, but we haven't even called cosine in here to verify that. And so we're not going to 100% prove that our code is perfect, but it will at least make me feel warmer and fuzzier knowing that we're doing okay. So instead of doing just two vectors like this, I want to do an array of vectors. I'm going to kind of hack around here a little bit and just modify the code some. Let's do vector 3D vectors array gets these two. We'll at least begin with these two, and need some commas here. And then down here we shall add some more. So vector 3D, and we'll do comma, 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 control L, control V, V, V. And in here, let's do 0.0f, 5.0f, and 0.0f. So now I'm just having one vector go down the y-axis in the positive direction. Let's do some negative values. I'm just randomly hitting keys on my keyboard here. 6.7f. And did I add? Yeah, I already added. Look at me adding commas. Alright, so now we have a very negative vector, but not all of it is negative. And then on this side, I think to compensate for that, we'll do 3.1f. And let's do a large number. Negative 99.6f, like so. So now we have components going in kind of all directions. We have a positive here and a negative here, and I think we're okay. We're going to need to store the size of this. So const uint, I believe we have a uint defined in our solution. Yeah, we had these type defs. That's right. Jamie engine type def uint. So let's just use that. Pound include. Oh no, it's miscellaneous. Miscellaneous type defs, and then using Jamie engine uint. Control end to go back down here. Const uint num. Let's do proper conventional case. Num vectors gets the size of the vectors array divided by size of star vectors. I've used this syntax with you before and explained it, but let me explain it one more time. This takes the size in bytes of this entire array, and then it divides that size by the size of one element in the array. In this case, it will give us 5 because there's 5 vector 3D objects inside of this array. And now I want to essentially do the test that we did before, where we do the dot product in one version, and then we call projectOnto in the other, and then test the result. And I'd also like to project both ways. I want to project this vector onto this vector, and then project this vector onto that vector. So we'll just walk through the array, projecting these vectors onto each other, and ensure that both the old algorithm, here's the old algorithm, and the new algorithm right here works in both cases. Everything adds up, so to say. So we'll project all those vectors in all those directions like so. So let's do a for loop. For uint I get 0, I less than the number of vectors, num, come on IntelliSense, num vectors minus 1. Okay, you'll see the minus 1 in a minute. And then basically you have to take all of this, cut it, and paste it into there, and do some formatting. Highlight this, Control KF. I could have hit the tab key there as well. And instead of target here, we're going to say vector, how about this, const vector 3D reference target. gets vectors sub I plus 1. And then above that I'll say const vector 3D reference source gets vectors sub I. So hopefully you can see why we did the I minus, or the num vectors minus 1, because we're taking the current vector and the next vector, and then we're projecting the source onto the target in this code and expecting the result to be equal. Let's just run this test and make sure that everything checks out. End is still green. Num vectors. What's the problem? Oh, of course, that's why IntelliSense died. I forgot my semicolon. Alright, let's build this. Hopefully, I'm hoping for green. Looks like we're still going green, but there's a problem with going green. We had these tests passing before, and I've added more tests, and they pass, theoretically, hopefully. I can't feel confident because I didn't break anything. So that's one reason why we do test-driven development. We do the tests beforehand so that, yes, we can see the red was there, and the red is now gone. I could go back to the unit. This is not ideal, but we could definitely go back to our unit tests for vector, not our unit tests, our implementation for the projectOnto function, where it's right here, and replace it with the code we had originally before the test pass, and just so we can see the red. But ideally we write all the tests first and then we see all the red. But old result, new result. Yeah, we're getting lots of red now. Anyway, this worked, but we have to project the other way. We have our source vector, which is this. Wait, it's the first one. Yep, we're projecting this vector onto this one, but we need to go the other way. And the way we could do that is by copying all this code, pasting it, and changing our source and all that. But I'm feeling a function coming on, so I'm going to let's grab all this code and put it right. Oop, not there. Let's do void test projection algorithms const vector 3D reference source const. This is going to go a little bit far to the right, so I'm going to put new lines here. Vector 3D reference target, and then we shall dump the algorithm right here. Highlight all of this. I could do Control KF, or I could do Shift Tab, and that will back it off one space. And I think that's good to go. So then now down here in the loop, all I have to say is test projection algorithms vectors sub I, project vector sub I onto vectors I plus 1. Control L, Control VV, and then let's project I plus 1 back onto vectors sub I. So this line will project this way, and this line will project this way. We cover all of our bases. No pun intended with vector bases. Control F5, build this, hopefully it compiles, runs, lots of green, feeling good about it. Now, before we're done with this, I actually want to write some code that involves a cosine, just so I can feel warm and fuzzy. I want to call the mathematical cosine function so I can feel warm and fuzzy that yes, we're doing cosines. We're what I actually said as far as dot product goes actually works. Yes, it does work for cosines. Let's do a cosine. We're going to do something simple though. I'm going to go Google an image and see if I can go find something. Hold on for a sec.